Okay, so all right. Well, first of all, your value as a person, as a student, is not determined by your grades on a midterm. Okay, it's not. There's no test or even your class grade. There's nothing that we can compute and say this is who you are. Okay, the midterm it's just a single test. Okay, and again, yeah, your value as a person not determined by your academics or your grades on your midterms or even what people say about you or whatever. Okay, you are you, and you are valuable just for being you. The median of the midterm was 28 points out of 31. There were 32 questions, right? 31 counted, and the second one, the last one was a bonus. So you could get over 100%. And so the median was 28, which is like a 90%. And then the first quartile was a 26, so that's like an 84%. So about, three-quarters of you scored over 26, over 84. So that's a very um, high score, um, and I'll credit you guys and say you guys studied hard and did well. Um, maybe the test was too easy. I don't know. The So some of us, we didn't do as well, and I don't want you guys to feel too bad. But if you scored in kind of this sub 22 range, we should probably talk, okay? And we should try to find out what's working, what's not working, put you on a plan to get you to succeed. So come visit me during office hours. Come talk to your TAs. There's free tutoring from the Stats Club, okay? If I don't know if you guys saw that. Um, the Stats Club, yes, we have a Stats Club. It offers free tutoring, so that's Tuesday evenings and Wednesday evenings at 6 to 7 p.m. in this building in room 5117. Okay, and so they're generally other undergraduate students who are majoring in statistics, so they know this stuff pretty well. And so, go see them, and we'll try to get you on track. Especially if you are a senior, a graduating senior, and you need this class to get out of here. Okay, that we gotta, and you find yourself in kind of this lower zone. Um, I want you to graduate, so I want, come talk to me, and we'll try to work something out. If but I have to be honest. There's I'm a little bit worried. So, uh, if we can figure out what is working or not working, um, that'd be great. And it's also possible that you're doing everything right, but just something's just not working out, and that's okay. That's part of life. Um, there's no shame in working hard and studying and failing. It's not a good feeling. It sucks when that happens, but there's no shame in that. Okay, that's just it's part of the learning experience. Okay, so anyway, that's the midterm scores. I keep the midterms. If you want to take a look at your midterm, you're more than welcome to do so. Come by during office hours, and I can pull up your midterm, and you can see what you got right or wrong. Um, and that's that. Okay, are there any questions before we get started on today's content? Yes, question.
Are individual scores put up yet?
They should be. They should be posted. Okay. Okay. There might be a handful of exams that I received a little bit later, and so those might need to be updated. Um, so okay. All right. We'll get started then. So today I'm going to wrap up chapter 5. This is our last bit on probability. And so far we've talked about you know, or rules, okay? You know what it means to be the complement of some event. We talked about mutually exclusive events and independent events. So I've got a clicker question for you guys. All right, so we'll say, let's say two events, A and B, are mutually exclusive. Okay? Both A and B have non-zero properties, non-zero probabilities. Okay, so these are both actual possible events. And the question is, could A and B be independent? Okay, let me get the clicker software started. All right, and so your answer choices, A is yes, they could be, but are not necessarily independent. B is yes, they are certainly independent. And C is no, they are surely not independent. Okay, so we'll get this going here. Okay, so you can talk to your neighbor about what you think the answer is. Okay, let's take a look. Okay. All right. Well, the answer is C. Okay. They are not independent. Okay. Let's take a look here. So let's just remind ourselves what it means to be mutually exclusive. Mutually exclusive means what? Probability of A and B is equal to 0, okay? Or in other words, if A happens, B is impossible, right? And vice versa. Okay, independent. What does independent mean? Independent events. Independent means probability of A given B is just equal to the probability of A, right? Okay. Or, you know, I could flip this around and say probability of B given A, this is equal to the probability of B, right? The labels A and B are arbitrary. So this means if A happens, then the probability of B is just what? The probability of B, right? Or the outcome of A has no influence on the outcome of B. Okay, which is just kind of the opposite of what mutually exclusive says, which says that if A happens, B becomes impossible. Independent says that if A happens, it has no influence, it has no impact on whether or not B will happen. Okay? Therefore, if they're mutually exclusive, they cannot be independent. Okay. Are there any questions on this? Does that make sense? No, we're all good? Okay. You guys do have a quiz in section this week, so tomorrow you have a quiz, and it covers chapter 5 stuff, okay? So probability, and I'm going to cover a little bit more, and the stuff I'm going to cover will also be on the quiz. So I'll try to give you as much help and guideline as possible. We got a question.
So are mutually exclusive events, are they dependent? Are they neither independent nor independent?
Yeah, if they're not independent, then that means they're dependent, okay? But don't confuse dependent for meaning cause and effect, okay? So just because if we say two things are dependent, the events are dependent, that just means they are not independent, okay? That means the probability of B given A is not equal to the probability of B. But it doesn't necessarily mean that event A causes or changes something about event B. It just means, you know, for example, if we know you are from California, we know that the probability that someone voted for Trump is lower than the rest of the nation, okay? And it's not that there's a causal magical effect there. It's just, that's just, you know, the probability changes. That's all we're saying. That's all we're saying, okay? All right, so let's take a look. Okay, so we're going to talk about sequences of independent events. Sequences of independent events. So if we say something like, if A and B are independent, that means the probability of B given A, this is equal to what? Just the probability of B, right? Okay, and then we had the probability of A and B is equal to the probability of A times the probability of B given A. Okay, and this is always true. Always true for all events A and B. Okay, so this should be in your notes from last Wednesday. Okay, but if A and B are independent, then the probability of B given A, this becomes a probability of B, okay? If A and B are independent. Okay, therefore, that means the probability of A and B just becomes the probability of A times the probability of B, okay? If A and B are independent. Okay, and this can be further extended for, you know, a bunch of events to many independent events. So let's say A and B and C and D are all independent. So meaning the outcome of A has no influence on B, C, and D. Outcome of B or C or D, none of them have influence on anything else. Okay, therefore, then the probability of A and B and C and D is equal to the probability of A times the probability of B times the probability of C times the probability of D. You just multiply them all together. If all of the events are independent. Okay, so let's try an example. Let's pretend we've come across a special coin. Let's say we have a special coin where the probability of landing heads for any one flip is 0.7. Okay, so when you flip the coin, it will land heads with probability 0.7. Okay, and we'll, for simplicity, we'll say the complement of heads is equal to tails. Okay, so then that puts what? Probability of tails to be, right? Okay, so our first question will be, I will flip the coin twice. I will flip the coin 2 times. What is the probability? Is there a giant motor turned on somewhere? The probability that the coin lands heads twice. We'll say coin lands heads both times. Okay. Well, this is the probability of heads on the first flip and heads on the second flip, right? So if we're asking what is the probability that the coin lands heads both times, we need heads on the first flip and heads on the second flip. Because the 2 flips are independent, meaning the outcome of the first coin flip has no influence on the outcome of the second coin flip, then we would say the probability of heads on the first and heads on the second is going to be probability of heads on the first times probability of heads on the second. And so I do 0.7 times 0.7, and I get 0.49. Okay. I can also just kind of do shorthand, and I can say probability of heads followed by heads is equal to the probability of heads times the probability of heads, 0.7 times 0.7. This is just the same way of writing everything that I had before, but with fewer words. Heads on the first and heads on the second. Okay. Well, let me give you guys another question here. Okay, and we'll say again we're dealing with our special coin such that the probability that it lands heads is 0.7. Okay, and we're going to ask, I will flip the coin twice. Okay, and I'm going to ask, what is the probability that the second flip matches the result of the first flip? Okay, and your answer choices are Okay, you go ahead and talk. You can talk to your neighbor to figure out what this means. I will flip the coin twice. What is the probability that the second flip matches the result of the first flip? Okay, so again, we're flipping the coin twice. Try to, figure out what outcomes this applies to, and figure this out. Okay, I'll start I'll open this up, and I'll let you guys work through this. All right, let's take a look. Okay, and that is correct. 0.58. So when we're talking about the second flip matches the result of the first flip, okay? We can list off our possibilities, right? With four just two flips, it's easy. You can get heads, 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 tails, tails, heads, or tails, tails, right? And for the second flip to match the first one, we are looking at the result heads, heads, and the result tails, tails. So we can say, okay, well, what is the probability of getting heads, heads, or tails, tails? Now these two are mutually exclusive, right? I cannot, if I flip the coin twice, I can't get heads, heads, and at the same time I've gotten tails, tails. So to calculate this, I just do probability of heads, heads, plus probability of tails, tails, and I don't have to worry about any overlap to subtract. There's no overlap. There's no heads, heads, and tails, tails probability to subtract. I mean, I could put that there, but it's going to be 0. Okay. Probability of heads, heads, this, because the first and second flips are independent, is going to be 0.7 times 0.7 plus tails, tails is going to be 0.3 times 0.3. All right, and so here I get 0.49 plus 0.09, and when I add these up, I get 0.58. And that is our answer to this question here. Okay. We'll extend this, okay, to a few more. Okay, so we'll continue dealing with our special coin, where the probability of heads is 0.7, and now let's say I will flip it 4 times. Okay, and my first question is, what is the probability I get heads all 4 times? Okay, so this is going to be the probability of heads, 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 right? Maybe this will be probability of 4 heads. This is equal to heads, 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 heads. So this is going to be probability of, they're all independent, so I can just multiply them through. And so here I would get 0.7, and this is where we use our exponentiation, and we just say, okay, well, this is just 0.7 raised to the 4th power. Calculator to do this. And I get 0.2401. Okay. And if I asked, what is the probability I get heads 0 times? Okay, that's the same thing as probability of 4 tails, right? If we're gonna, flip it 4 times. This is the probability I get heads 0 times. This is the probability of 4 tails. So this is going to be probability of tails raised to the what power? To the fourth power. So I have 0.3 raised to the fourth power. And I get 0.0081. So the probability of getting 4 tails or getting 0 heads is 0.0081. Yes, question?
If we did 1 minus the probability of 4 heads,
Yeah,
that's only excluding the possibility of getting 4 heads, right?
yeah, it's only excluding the possibility of getting 4 heads.
It's, what's it called? That's the same as asking what's the probability of at least 1.
It's at least 1 tail. Yeah, we'll take a look at this. Okay, so that's actually that's kind of our. We'll go there. We'll go there soon. Okay. All right, but before we go move on, everything's okay with this? 4 heads, all 4 heads, or 4 tails? Okay, let's take a look. What if I said, what is the probability? Okay, again, flip our special coin 4 times. And I ask, what is the probability I get heads on the first 3 flips and tails on the last flip? Okay, so the sequence of outcomes has to go what? So my first, my second, third, and fourth, it has to go heads, 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 tails, right? And so here I will have 0.7 times 0.7 times 0.7 times 0.3, 0.7 to the third times 0.3, 0.7 to the third times 0.3 on my calculator gives me 0.1029. This is distinct, it is similar sounding, but is different from what is the probability that at the end of 4 flips, we see 3 heads and 1 tail. 3 heads and 1 tail, kind of in total. 3 heads and 1 tail in total, meaning, you know, kind of there's implicitly it says the order doesn't matter. Okay, and so now I have several outcomes that satisfy what we've got going on here, right? So there are possible, so some outcomes that work. We have possible outcomes. If I flip it 4 times and I want 3 heads and 1 tail, I can get this outcome, heads, 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 tails, where tails is my last one. I can get tails to be the third one. I can also get tails to be the second. And tails to be the first. So I have 4 possibilities. This one is 0.7 times 0.7 times 0.7 times 0.3. We said this is 0.7 to the third times 0.3, which is equal to 0.1029. So far, so good? Okay, what's the probability of this one? Okay, well, we can go through the sequence, and I would have 0.7 for the first. The second one is also heads, so it's going to be 0.7. The third one is tails, so I do 0.3, and the last one is heads, so I do 0.7. So it's 0.7, 0.7 times 0.3 times 0.7. Okay, but because in multiplication the order doesn't matter, this just ends up being 0.7 to the third times 0.3. And so I also get 0.1029. Okay, and we can do the same for the other two, and you can check yourself, but they will also be 0.1029. So the total probability of 3 heads and 1 tail, any order, is 4 times 0.1029. So I get 0.4116. Yeah. Okay. This kind of problem. This is a special problem. This is known as a binomial problem, and we will explore this further on Wednesday. Okay. This will not be on the quiz. Not on the quiz. I don't expect you to have to list out every single arrangement that works out. Okay. I think this question is fair for the quiz. Okay. Fair for quiz. If I tell you the exact order of what should happen, heads on the first 3 flips and tails on the last one, that one should be relatively easy to do. But if I just say the order doesn't matter, that one's a little bit trickier because you have to figure out all the sequences. Yes, question?
So the homework covers up to that question, fair for quiz, or are there some questions in the homework that are a little more complicated than the quiz?
Are there questions in the homework that are more complicated than the quiz? I don't think so. I don't think so. Okay. Let me give you one more set of questions here. Okay. And this is okay. We'll just stick with our special coin example, right? So in all of these examples, I've been using probability of heads to be equal 0.7, but I mean, we could easily change it to something else, right? Maybe you're dealing cards out of the deck, okay, but it's not a regular deck. And we can say the probability of getting a red card is 0.25, and the probability of getting a black card is 0.75 or something like that. Or you know, you're playing some other game, the probability of winning is 0.4 and the probability of losing is 0.6. Okay, it's all kind of the same here. Okay, so here we're going to say we still have a special coin where the probability of heads is 0.7, and we're going to flip it 4 times. Flip the coin 4 times, and I'm going to ask the question, what is the probability we get tails at least once? Okay, at least one time. We get tails at least one time. Okay, this is not the same. So, okay, so we'll say probability of at least one tail. Okay, this is technically equal to the probability of one or more tails, which would be the probability of getting one tail, any order, plus the probability of getting 2 tails in any order, plus the probability of getting 3 tails, plus the probability of getting 4 tails, right? All of these have implicitly any order. Okay, are there any other possibilities? 5 tails, do I have to worry about that? No, because I'm only flipping it 4 times, right? So this is these are all the outcomes that are included in at least one tail. And we figured out probability of one tail any order was, what was that? 0.4116 from the previous slide. Okay, but then, you know, this and this and this, these would be, you know, tedious to calculate. All right, is there a better way? And there is a better way, okay? Whatever event we are talking about, okay? And this is true not just for flipping coins, but for any event that we can imagine in life, okay? Getting married, getting an A in a class, whatever it is, okay? Whatever event you're talking about, there's only two possibilities that will happen in your life, okay? Either it happens at least one time, or it never happens, okay? Whatever we're talking about, it's either never going to happen in your life, or it will happen at least one time. And so, when we're talking about getting at least one tail, this is the complement of getting 0 tails. Okay, so we're either going to get 0 tails or we're going to get at least one. Whatever it is that we're talking about. It's either going to happen 0 times or it will happen at least once. Okay, well, what's the probability of getting 0 tails? This is going to be 1 minus the probability of all 4 flips are heads. And so this becomes 1 minus 0.7 raised to the 4th, which is 1 minus 0.2401. Yeah, 0.2401. And get 0.7599. So if we flip this coin 4 times, we have about a 76% chance that we get tails at least one of those times. Is that okay? Yeah. All right. So if I said, what's the probability we get heads at least one time? I flip the coin 4 times, what's the probability to get heads at least one time? What do we do there? Yeah, 1 minus the probability of all tails. Yeah, so we're going to say, what is the probability of getting at least heads one time? So this is probability of at least one head. So this is the complement of getting 0 heads, right? At least one head is the complement of getting 0 heads. 0 heads is the probability of getting all 4 tails, okay? All 4 are tails. So we do 1 minus 0.3 raised to the 4th. This is 0.0081. And so we get 0.9919, I think. Yeah. And there's our answer. Probability of getting at least one head. So this again, if probability of heads is 0.7, and we're going to 4 flips, probability of at least one head is 0.991. Okay, we'll end here. You can expect to see a few of these types of questions on tomorrow's quiz. So I would say study the examples that we've gone over in class, and we'll see you guys on Wednesday.